In this video I wanted to talk about exponential equations and how to solve them. So exponential equations are basically just equations where the variable that you're trying to solve for in the equation is in a power, or it's in an exponent. And what I mean by that is, for example, if we had the equation 2 to the x equals 8, that would be an exponential equation because x is in the exponent. All right, and we could solve for this. We could say, okay, 2 to the x power equals, and what is 8 actually equal to? Well, it's equal to 2 to the third power. And that would tell us that x is basically equal to 3, right? Now that's just an example of solving for an exponential equation. But what if the numbers aren't that simple? Well, there's another way to solve it that's a lot more versatile, and it can be applied to a lot more situations. And it involves logarithms. So hopefully you have a background in logarithms by now. Okay, so let's say we had the equation 2 to the x equals something like 2050. Okay? All right. Now 2050, I'm pretty sure, isn't a multiple of 2, so we would have to solve for this using logarithms. And how we would do that is we would say log of 2, log base 2, of 2 to the x equals log base 2 of 2050. And what that's basically saying is what log is it's basically a function that says, okay, I'm going to take this number and I'm going to find 2, well, which is the base, to the what power equals this number. Well, 2 to the what power equals 2 to the x. Well, 2 to the x power equals 2 to the x. So we're just going to output an x. If that explanation was too fast or a little confusing, I suggest you do some research on logs first, because this video isn't really meant to give you a background on that. Okay, but anyways, and then we would find out what the number is of log base 2 of 2050. So, and we have solved for x. Okay? Okay. Now this complicated method doesn't always, well, not complicated, but a little bit messy sometimes, doesn't always have to be used. Sometimes, if you have, for example, 2 to the x equals 32, then there's an alternative way to solve this. And that's because 32 is actually 2 to a certain power. So it can actually be converted to 2 to the 5th, right? Now this only works for numbers, for example, if the numbers on the other side can actually be expressed as this base to a certain power. Because then we can say 2 to the x equals 2 to the 5th, which means x equals 5. Or for example, if we said 3 to the x equals 27, that's the same sort of situation. 27 can be expressed as 3 to the power of 3, right? But if we had something that was like 3 to the x equals 100, 100 cannot be expressed as 3 to a certain power, right? It's just 100. And in that case, we would have to use log base 3 of 3 to the x equals log base 3 of 100. Okay? So that would give you probably not a really nice number as a solution, but it will still give you a solution. Okay, moving on. So sometimes functions or equations will have more than just the x, more than just one variable in the power. And what I mean by that is sometimes it'll have like maybe 4 to the power of x minus 1, right, equals 16 to the power of 3. Okay? Now, we can use some of the exponent rules that we did in the last video, and we can basically say that 16 is the same thing as 4 squared, and then we can put that to the third power, right? That's equal to this. Okay. And we know we have to multiply these, so 4 to the 6th power equals 4 to the x minus 1. And we would say x minus 1 equals 6, which means that x equals 7. So that's what I mean is sometimes x, there will not just be x there will be like x minus 1 or x minus 2, or like 2x, x to the power of 3. All sorts of different things can be in the powers that you might need to be prepared for. So let's do another example of where it's not just x in the power, and it's not something where you can convert to a similar base. So we can't convert 16 to 4 anymore. So let's say 3 to the x squared power, okay, equals 34. Okay. So what would we do here? Well, we would say log base 3 of 3 to the x squared, right, equals log base 3 of 34. Okay, and that's basically saying that x squared equals log base 3 of 34. And then we can simplify a little bit more. We need to square root both sides. So we would say x equals the square root of log base 3 of 34. So not a nice number, but you see we could apply logarithms to this sort of equation as well. So it was actually x squared in the power, not just x. So basically the goal of solving exponential equations is just to get the wherever the variable is out of that power by using logarithms or converting to a similar base, as you saw maybe in this example, where we converted 16 to 4 squared. And then we converted that to 4 to the 6 because it was to the third power. But usually you would use, or if you want like a sort of solution, a way to solve these types of equations that's more versatile, I would suggest just using logs, but it can get a little bit messy. So if it's very clear to you that, like, for example, this is a very clear equation where it's very clear where you could just convert 16 to 4 squared. But sometimes, often, you'll need to use logarithms. So that pretty much concludes this video. Thank you.